Hello everyone, I'm Qingzhi. Today I'm going to introduce DBEst++, an approximate query processing engine. In the era of big data, it takes a long time to get an exact SQL result. Here is an example showing the query response time from Hive. Hive takes around 1 hour to get a result for the TPCDS dataset. AQP aims to reduce the query response time by providing an approximate answer. With DBEst++, we achieve orders of magnitude reduction in query response time. For instance, for query 4 and 5, DBEst++ takes around 30 milliseconds to respond. Now we talk about the design choice. We firstly revisit the universal model approach, where models or samples are generated and maintained to answer all queries for a schema. We argue that it is not a good solution to keep a massive model for all queries. Instead, we adopt a model per query template approach. We develop lightweight models to answer queries of the same query template. This is how we define the query template. A template consists basically of the column sets involved in the query. It turns out that such models can offer higher accuracy and fast query processing, while requires only tiny memory footprints. Here we show the system architecture. The main components include the SQL parser, the model container, where models are stored, the SQL executor, which produces approximate answers using models. In DBEst++, we use regression models and density estimators to produce the result. Here, we show the formula for aggregate function, sum, count, and average. This is the structure of mixture density network. The output of MDNs are a mixture of Gaussians. We use MDNs for both density estimation and regression tasks. Here, we explain how models are used to answer queries. Firstly, word embedding is used to transform categorical attributes to numerical values. After that, we feed these representative points to density estimators and the regression model, and the output from the models are aggregated to produce the final answer. We have shown in the papers that, compared with the state-of-the-art AQP engines, DBEst++ pushes the lower bounds of the required space, and it offers top-notch query execution time and high accuracy. Please refer to the papers for more details. Now, let's talk about the user interface. You can interact with DBEst++ using a terminal or use the Python API we provide. Here, we show the supported queries. You can show all the models. You can drop a model. You can set a parameter to fine-tune the model. Also, you can create a model and use the model to answer a query. In the demo, we provide 5 query templates, 3 for the TPCDS dataset and 2 for the flight dataset. We also provide Jupyter notebooks, so you could interact with DBEst++. We use the same workflow as described in the paper. You need to define the query template, initialize the parameters. After that, you can train the model and use the model to answer a query. You could also make some plots if you want. We will be executing online these 5 query templates, for which we have built models, and we will be showing their response time against Hive. The notebooks are available here. Here, we show the performance of DBEst++ for query template 1. The left figure shows the histogram of the data, and the right figure shows the distribution from DBEst++. For demonstration purposes, we only show the results for one group. Clearly, the distribution from DBEst++ resembles the actual histogram. We also show the result for the flight dataset, and the same conclusion holds. Here, we summarize the performance of DBEst++ for query templates we provided in the demo. Clearly, DBEst++ wins by orders of magnitude in both query response time and space overhead. Here, we introduce DBEst++, an approximate query processing engine. It relies on machine learning models to make predictions. We provide Jupyter notebooks to demonstrate DBEst++. Please check the GitHub repository for the complete workflow and experiment. Thank you.